Hi everyone, welcome once more to this channel. So we're giving out the solution to Physics Practical Alternative A, Practical May, June 2025. So our focus is going to be on question number 1 and number 2, question 1 and 2. Look at number 1 question. The diagram is sketched here. We have two retort stands, one on the left and one on the right hand side. Then the retort stand we have it clamped, or we have a spiral spring holding the retort stand at the 5 cm mark. We also have a thread holding the retort stand at the 95 cm mark. And then L, the length between the 5 cm and 95 cm. That means L is 95 minus 5. It's going to give us 90 cm. Then we have also a retort stand close to the end of the meter rule, the end A or the meter rule, that is on which a meter rule is clamped with a pointer, Y1 pointing at the 5 cm mark, or whatever initial reading you have. Then have another diagram for the same system. This time around, we have a mass M, which is a 100 gram mass, hanging at a distance S from R. Mind you that R is the 95 cm mark. Then, and when that mass hangs, the meter rule will go downwards to a new distance, which is Y2. So as you can see, Y2 should be more than Y1. So you can see that. So let's go to the question. So question says, use the diagram above as a guide to carry out the following instructions. I, with no load on the rule, attach the spring securely to it at T, such that AT is equal to 5 cm. II, attach the loop of the thread securely to the rule at a point R, such that RB is equal to 5 cm. So you can see in the first diagram where the spring is at 5 cm from the zero end. The second diagram B, where the thread is 95 cm from the 100 end. It should be 5 cm from the 100 cm end, and that should be at 95 cm. Triple I, ensure that the rule is horizontal as shown in Fig 1A. IV, record the pointer position Y1 on the vertical rule. V, record the distance TR equal to R. That equal to R, that TR is the distance from the 5 cm to the 95 cm. That is 95 minus 5. You can see the L there. That should be 90 cm constant. Question VI. Suspend the mass M equal to 100 gram at the point P in the horizontal rule such that PR is equal to S, which is 20 cm. So the mass 100 grams should hang at a point P. So PR, which is equivalent to S, 20 cm. So let's look at the diagram and explain. So you can see the point S on this Fig IB, where the mass M is hanging. That point S is 20 cm from R. Mind you, R is 95. So 20 cm from R is going to be 95 minus 20, which is 75. That means the mass M is hanging on the 75 cm mark. Record the new pointer position Y2. So as I said, when you hang the mast, the meter rule will move downwards, or the spring will extend. That'll give you a new position Y2. Then VII says evaluate D equal to Y2 minus Y1. IS, without changing position Y and R, repeat the experiment for S equal to the 5 cm, 30 cm, 35 cm, and 40 cm. For each case, record Y2 and calculate D. S, tabulate the results. S1, plot a graph with D on the vertical axis and S on the horizontal axis, beginning each axis from the origin. SI, determine the slope S of the graph. Then SIII, determine the value of K in the equation K equal to 100 over D. So let's go to the table of value for now. Look at the other question. So solution to the equation number 1, the table of value. You have the first item that is y1. That is where the pointer was before the mass was hung on it. So the y1 is 5.0 cm. Tr, which is equal to L, which is the distance between the thread and the spring, is 90.0 cm, which is 95 minus 5 on the diagram. Then we look at the table. We have serial number, the first 1, 2, 3, 4, 5. We have y2 cm. We have D is y2 minus y1, all in cm. We have S also in cm. So for the first row, we have 7.00, 2.00, 20.0. Second row has 7.50, 2.50, and 25.0. Third row have 8.00, 3.00, 30.0. Have fourth row 8.50, 3.50, 35.0. Fifth row 9.00, 4.00, 40.0. You start wondering, how did I get, or how did we get calculate our D? Remember that y2 is obtained from the experiment. So by moving by varying the distance s, the mass to different distances of s, then the going to be extension have new values of y2. Then how did I get D? D is y2 minus y1. Y1 is constant. That was is out of the table. Y1 is 5. So to get y1 in the first row, that'd be 7 minus 5. That gives us 2. Y1 is to get D in the first row, sorry, it's going to be 7, which is y2 minus 5, which is y1, giving us 2. To get D in the second row, it's going to be 7.5, which is our y2 minus the same 5, will give us 2.5. To get our D in the third row, we're going to be 8 minus 5, y1, which is going to be give us 3. To get D in the fourth row, we're going to be 8.5 minus 3, that gives us 3.50. To get D in the fifth row, we're going to be 9 minus 5, that gives us 4.00. So this is the table once more. So let's look at the graph. So for our graph, I have a plot of D centimeter on the vertical axis against S centimeter on the horizontal axis. So our scale from the readings we have on the D axis is, we have 0, 1.0, 2.0, 3.0, 4.0, and so on. So that means we're using two buses for 1 unit on the D axis. And you know that a bus here is 2 centimeter. That means we're using 4 centimeter to 1 unit on the vertical or D axis. Then going to the horizontal axis, have 0, 10, we have 20, 30, 40, that on the S axis. We're also using 2 buses, but now to 10 units. What it means, we're using 4 cm to 10 units on the horizontal axis. So look at the shape of our graph, a very good graph, with almost all the points on the straight line. The straight line graph, and then we have an intercept close to the origin. So that's the nature of the graph we have. So let's look at the slope. Our slope, we'll look at it and then look at the calculation of slope and then continue. SII says find the slope. The slope is the change on D axis all over the change on S axis. You know that S is in cm, D is also in cm. So we took our slope from the coordinates on D axis 4 and 2, that is 4 minus 2, and then on the S axis 40 and 20, which is 40 minus 20. No need to combine units because the units are the same. CM cancel each other. So 4 minus 2 give us 2. 40 minus 20 give us 20. Divide 2 by 20, we'll have 0.10. So the slope of this graph is 0.10. SII says we should evaluate K equal to 100 over D. 100 over D. Our D is 20 centimeter. How do we get our D? The D is, okay, let's correct the error. Our D is 2 cm rather, not 20 cm. So how do I get that D? Go to your graph, the slope. The numerator on the slope is delta D, which is 4 minus 2. So that is represent your D. The change on D axis. 4 minus 2 is 2. So that is your D here. So 100 over 2, that gives you 50 per centimeter. 50 per centimeter. So we don't know what it means. Perhaps that could represent the center of gravity of a uniform meter rule. Question SIV says, use the graph to determine the pointer position Y2 when S is equal to 32.5 cm. So use the graph to determine the pointer position Y2 when S is at 2.5 cm. So go to the graph. So to solve it, you go to the graph, locate the S axis and locate 32.5 on the horizontal axis. So you can see the dotted lines. Then move it up until you get the graph. Then move the graph, the line to the horizontal, to the vertical axis, that is to the D axis. And then read off that value there. That value there is 3.2 centimeter. So when S is 32.5, our D is 3.2 cm. So we'll now go back to the solution. The solution says when S is 32.5, D is 3.2 cm for our graph. Then how is D calculated? D is Y2 minus Y1. So you make Y2 the subject since it's what you're looking for. Y2 now becomes D plus Y1. So Y2 now becomes 3.2, which is the value of your D plus 32.5. And that gives us 35.7 centimeter. Number SI says state two precautions SV. Two precautions taken in the experiment. Precautions 1 says, I avoided error due to parallels when reading the pointers by placing my eyes at eye level and perpendicular to the scale. 2, I ensured the meter rule remained horizontal and balanced before loading. Then question 1BI says, should state the principle of moment. So 1BI, the principle of moment states that for a body to be at equilibrium under the actions of forces, the sum of clockwise moment about a point must be equal to the sum of the anti-clockwise moment about the same point. For a body to be at equilibrium under the actions of forces, the sum of clockwise moment about a point will be equal to the sum of anti-clockwise moment about the same point. Question 1BII says a block of mass 0.05 kg is suspended on a vertical spring of force constant 5 Newton per meter. If the block extends 0.08 meter below the equilibrium position, calculate the magnitude of the net force on the block. Take your acceleration due to gravity as 10 meters per second squared. To solve the problem, we'll find Fg. Fg means the force of gravity on the body or the weight of the body. You can still call it W or weight. So Fg or weight is given by mass times acceleration due to gravity. The mass of the body is 0.05 times 10. That gives us 0.5 Newton. We'll now find Fs, which is the force on the spring. So Fs given by Ks, which is the force constant times extension. We're going to be 0.08 times 5. That gives us 0.4 Newton. The net force becomes the weight minus the force on the spring. Fg minus Fs. That becomes 0.5 minus 0.4. And that gives us 0.1 Newton acting downward. So we'll go to question number 2. Question number 2 says, you are provided with a drawing board, drawing paper, 4 optical pins, rectangular glass prism, and other necessary materials. Study the diagram below. We have a diagram for a prism block given to you there. We have the incident ray. falling on the prism, and you have the pins P1 and P2 on the incident ray. Okay, so you have a normal drawn on the face AB. That normal is WSY. It extends to the that normal extends to the face DC, WSY. Then you have the outline of the prism ABDC. You have an angle theta, the grazing angle theta, given there between the incident ray and the face of the prism. That means they did not give you the angle of incidence. So we have the glazing angle giving us the theta. So not the angle of incidence. We don't want to go to the question. We have also on the face DC, we have okay, the incidence ray is RS, yes, and the incidence ray is extended from point S to point Z, which is on the face DC, while the normal is extended from WS down to point Y, which is on the face DC also. They will have the search pins P3 and P4 on the other side of the prism, that is on the face DC. So that you see that this experiment, there is no mirror was brought out. It's only prism you're using. So look at the question. Say use the diagram above as a guide to carry out the following instruction. 1. Pin the drawing paper on the drawing board. 2. Trace the outline ABCD of the rectangular glass prism on the drawing board provided. 3. Remove the prism. Select a point S on side AB such that it is 1/4 of AB. IV. Draw the normal SWSY. Also draw the line RS to make an angle theta, which is 75 degrees, with AB at S. IV. Fix 2 pins at P1 and P2 in line RS. Replace the prism on its outline. VI. Fix 2 other pins P3 and P4 such that they appear to be in a straight line with the images of the pins at P1 and P2 when viewed through the prism from side DC. VII. Remove the prism and the pins P3 and P4. Draw a line to join P3 and P4. VII. Produce a line from P3 and P4 to meet the line DC as Z. Draw line SZ. IL. Measure and record the values of YZ and SZ. S. Evaluate alpha equal to YZ over SZ and cos theta. SI. Repeat the procedure for 4 other values of theta equal to 65 degrees, 65, 55, 45, and 35 degrees. For each case, evaluate alpha and cos theta. SII. Tabulate the result. SIII. Plot the graph of cos theta on the vertical axis and alpha on the horizontal axis. SIV. Determine the slope of the graph. So before we go to the table, let's look at the diagram once more. So look at the diagram once more. The prism outline is ABDC. Look at the normal. The straight line WS is the normal. It's extended straight to Y. Y is the point on the face DC. Look at the line of incidence or incidence ray, which is RS. And look at the pins, optical pins P1 and P2 placed there, which should be 4 cm apart. Then look at S, the point S, where we drew the point of incidence, where the normal is drawn and where the angle of incidence is drawn. The question says that AS, that point, that distance from A to S should be 1/4 of the face AB. So you have to take your rule and measure the width, that is the AB, the width of your prism. So whatever you get as the width, divide it by 4. So let's assume that I measured AB in my prism and I got 12. Divide by 4, it becomes 3. That means AS will be 3. I'll now have to mark out 3 from A to S will be 3 cm. Then I will draw my normal and my incidence ray at that point S, which should be 3 cm. Assuming that my prism is maybe 10.4, AB is 10.4. I'll find 1/4 of 10.4. That give me around 2.6. I may use my ruler and measure from A to S. That becomes 2.6. At that point, I draw my normal and draw my incidence ray. So that value, that 1/4 value you're going to measure, that is 1/4 of AB, should be constant all through the experiment. So for each of the angle you are doing, you must maintain that distance 1/4. So from A to S of whatever prism you're using. Then you can see the search pin, that is P3, P4, to locate the images of P1, P2 in the prism, then and so on. So what are we measuring? So our interest here is on the angle theta. The angle theta is not the angle of incidence, it's the glazing angle. So how do we get theta? Theta is what the relationship between theta and angle of incidence. The angle of incidence is the angle that should be here. So look at that place where I inserted I, between the normal and the incidence ray, where it has small I, that's the angle of incidence. I just inserted it now. That is the angle of incidence. So, but what we are given to measure is theta. So what relationship between I and theta? I plus theta is 90 degrees. So what it means that if my theta is 75 degrees, my I is going to be 15 degrees. If my theta is 70 degrees, my I is going to be 20 degrees. And so on. The relationship is that the two of them add up to give you 90 degrees. So we'll now go to our table of values. Number 2, table of values. We have serial number 1, 2, 3, 4, 5. Theta in degrees, 75.0, 65.0, 55.0, 45. So theta will come again. Theta is 75.0, 65.0, 55.0, 45.0, 35.0. YZ CM 2.00, then 2.10, 2.80, 3.40, 4.50. Our SZ in CM 6.50, 6.80, 7.00, 7.30, 8.90. Our alpha, which should be YZ all over SZ, divide YZ by SZ, divide 2 by 6.5, you get 0.3077. Divide 2.1 by 6.8, you get 0.3088. Divide 2.8 by 7, you get 0.400. Divide 3.4 by 7.3, you get 0.4658. Divide 5.0 by 8.9, you get 0.5056. Cos theta. So cos 75 gives us 0.2588. Cos 65 gives us 0.4226. Cos 55 gives us 0.5736. Cos 45 gives us 0.7071. Cos 35 gives us 0.8192. So we're going to plot now cos theta on the vertical axis against alpha on the horizontal axis. We now have our graph cos theta on the vertical axis against alpha on the horizontal axis. So let's check our scale. On the vertical axis, we have scale 0 starting, then 0.2, 0.4, 0.6, 0.8, and so on. So look at the scale, 2 buses to 0.2, 2 buses, a bus is 2 cm, that means 4 cm to 0.2 unit on the vertical or cos theta axis. So let's go to the horizontal axis. We have 0.2, 0.4, 0.6, the same scale. So on the horizontal axis, we still have the same scale, 4 cm to 0.2 unit on the horizontal or alpha axis. So we have our beautiful graph there, where we have only about, we have about 3 points on the straight line and 2 points close to the straight line. That is giving us the best line, selecting the best points. So let's look at the slope. So we took our slope, widen our slope at the vertical coordinates at 0.8 and 0.4. That's why we took our slope on the vertical axis. Then going to horizontal axis, our slope, we took our slope around, what I say, 0.5 and 0.33 on the horizontal axis. So let's go to calculation of slope. So SIV, slope, it's going to be change on cos theta axis all over change on alpha axis. So from where we took our slope, 0.82 minus 0.40 on the vertical axis all over 0.5 minus 0.33 on the horizontal axis, and that gives us approximately 2.5. So we'll start wondering, what does 2.5 represent? Because 2.5 cannot be the refractive index of glass. So we were confused and we have to try to take the slope for another place, which is not this under coordinate, which is different from this. And we got the same value of also 2.5. So that 2.5 should present the 1/4 of the face where we drew the normal, because our prism, for the prism we use is a prism of width 10.4 and 1/4 of it is 2.6. So you see that the slope is an approximate of 1/4 of the face of the prism that we use, which is a 10.4 by width. 1/4 of it is 2.6, showing that is a good approximation or a good work. Now we go to precautions. SV, precautions. 1, I avoided error due to parallels while locating the images using the search pin. Number 2, I avoided error due to parallels in reading the protractor, and I ensured that there was adequate source of light. Number BI says, state the second law of refraction. Second law of refraction says the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant. The constant for any, 4 is missing, after constant for any given pair of media. Let's correct it. So I brought in the missing word. The ratio of the sine of angle of incidence to the sine of angle of refraction is a constant for any given pair of media. The ratio of the sine of angle of incidence to the sine of angle of refraction is a constant for any given pair of media. So that is the second law of refraction, the Snell's law, I would call it. The next question, BII, says light travels from air into glass, or refracting index 1.5. If it is refracted at an angle of 19.5 to the normal, calculate the angle of incidence. Light travels from air into glass, or refracting index 1.5. If it is refracted at an angle of 19.5 to the normal, calculate the angle of incidence. To solve this problem, the refracting index n is 1.5, angle of refraction is 19.5, then I is unknown. So use the equation n equal to sine I over sine r. Making sine I the subject, sine I becomes n times sine r. Substituting, that becomes 1.5 times sine 19.5. So sine r now becomes sine 19.5 is 0.3338 times 1.5. That gives us 0.5007. Then I becomes sine inverse of 0.5007, and that gives us 30 degrees. 30 degrees. Then this is at the end of number 2. Before we wind up in this video, we're going to illustrate or show. See that this number 2 is a very simple question, even simpler than we expected. So number 2, we're going to show how you can construct. Briefly, you can use 2 different angles to show how you can construct those angles without doing the experiment. So we're going to show that. So you stay connected. We're going to show it as quickly as we can, how you can connect, how you can construct those angles, or how you can do the tracing without doing the experiment. For the particular experiment, it's a very simple thing to do. So let's go to it. Now, to construct each of those angles, you need the following. You need the prism, the glass block. If you don't have a glass block, you can take any measurement. You can take measurement of width. Let's say 10, like my width is 10.4, while my breadth is 6.5. 10.4 by 6.5. So we can still take 12 by 7. 12 width and 7 breadth. So if your prism has a different dimension, 10.4 and 6.5 from my own, our readings will vary. Our readings will vary because your slope will determine the 1/4 of your width. So if I'm using my own, it should be, you don't have the prism of this size, you can just measure out accurately 10.4 by width, both up and down, and then 6.5 by length. That is it. So this is 10.4. This side is 6.5. That's what I mean by that. So having done that, the first, we need protractor, need pencil, you need ruler, you need optical pins also, and then you need a white paper. So, but for the sake to make this somehow eligible, I'm going to trace the diagram using pen instead of using pencil. You're going to use pen to do that. When the examination, you don't use pen, you use pencil, you use pencil, you use pencil, not pen. I repeat myself. So everything you're doing here is use a pencil. So I'm going to trace it with pen to make it clearer and legible. And then you see how it's being done. It didn't take any time. I will only do 2. Anyone I do, look at the readings and then compare what we have there, whether it is right with this or is wrong. So let's draw the outline first. So I've traced the outline. You can see it there. A, B, using the prism A, B, D, C, compared to the main diagram A, B, D, C. So what the next thing to do? I'm going to measure the length AB. The length AB from this prism is 10.4. So that is AB. Use a ruler and measure it 10.4, or according to your own prism. Then divide the 10.4 by 4, 1/4 of it. I'll get approximately 2.6. So I'm going to measure 2.6 from end A and mark that point as S. 2.6 from the end A. So let's do it. So you can see the point mark S from A to S is 2.6, which is 1/4 of AB. So I have measured it out. So next thing now is, if you look at the main diagram, is to create the number WSY and then create angle theta. So let's see. So I'll go to the table where you have those angles theta we're asked to use for the experiment. Theta on the second column, 75, 65, 55, 45. So this one has been done already. So I will select one of the angles to illustrate this. Let me select the last one there, angle 35 degrees. Theta at 35 degrees. So let's select 35 and then go back to the diagram. After that, I'll pick another one also. Maybe I use 2, and then the other ones you can, with 2, you can do every other one there. Okay, now I want to mark out my normal and my theta, which I selected 35 degrees. You play the protractor so that its baseline will cover AB and the midpoint of the protractor be at S. The baseline of the protractor, look at the baseline, the line at the middle here. We'll cover the line AB will be covering it, will be on top of it. and the midpoint of that angle 90 will be at S. To get your normal now, I will now spot at 90. You spot at 90 degrees with your pencil. That is your 90. And then to get 35 degree theta, you count from 0, not from 90, because the angle is the glazing angle. Count from 0, 35. So here is 0, 10, 20, 30, 35. You spot at 35. You spot at 35, correct it. Then when you are done that, I'll correct it, the error here. So we have corrected it. So when you are done that, you draw a line from that, the place is spotted 90, draw it straight until it reaches the point DC. Then draw another line from 35 degree until it reaches the point S. I repeat myself. Draw your normal from that spot on 90 until the face DC. And then draw your incident ray from the 35 degree, not incident ray, so the glazing angle theta, from that point 35 degree to the point S. So you can see the line drawn, the normal drawn from W until passing through S until you reach the point labeled C. It hits the face DC. And the incident ray drawn from the point you mark 35 till you hit S. Theta is 35 degree, you can see that. They do some construction. You use your pin and perforate 2 points. Those 2 points should be at least 44 cm apart. So P1 and P2. Look at your arrow showing the incidence ray is coming. So you have to do all these constructions. You can see that it looks more like the main diagram. You can see that. So remaining certain things to do now. You can compare the two. So next thing now is this. The ray that is coming down. So we're not going to extend the incident ray RS just like that. No. Before we extend the incident ray, we have to calculate the angle of refraction. That's the only calculation we're going to do here. We have to calculate an angle of refraction before we now bring down the incident ray, before we bring down RS. You don't just draw it straight. No, it's not done that way. So to calculate angle of refraction here, you have to find your incident angle. This angle should be an angle that should be there, angle of incidence. So the angle of incidence should be 90 minus theta. That becomes 90. Your theta there is 35. That gives us 55 degrees. You see that? When you obtain that, you go to Snell's law that says N equal to sine I over sine R. That is Snell's law. You make sine R the subject. So sine R becomes equal to sine I over N. You see, what is your I? Your I is 55, no longer the 35 that you measured on the prism. No, you use the incidence angle. That becomes sine 55. If I index of the glass, I'm taking 1.5. You can still use 1.51, 1.52 to create variations using 1.5, which is a regular number. So find sine 145 with your calculator or 4-figure table. Sine 55, sorry, with the 4-figure table. And then sine 55 is giving us 0.8192 divided by 1.5 with the denominator there. So we divide, getting 0.5461. Then how do you find your angle R? R becomes sine inverse of 0.5461. You use your calculator and find the sine inverse of that, and that gives you 33.1 degrees. Approximately 33 degrees. So this is the angle of refraction on the face AB. So we'll go back to the diagram. So on the diagram, you measure your angle of refraction, which is calculated as 33.1 degree. How do you measure? You bring your protractor, turn it the other way around. Take the baseline to cover AB, you see how we do it, and then let 90 degree rest on the normal, on the opposite side. So let's do it very well. Okay. Then count, read off 33.1 degree, the angle of refraction. Do we start from the place to read? No. We start from 90 to count at 30 degrees. So where do we get at 30 degrees from 90? 90 minus 80 is 10. 90 minus 70 is 20. 90 minus 60 is 30. So 33 is count values after 60. So 90 minus 6 is 30. Then count 3 points. You have 33. Or you cannot actually get 0.1. So you can get approximately 33 degrees. So that is, it should be around. Let's position this thing very well. We'll count. The table should be horizontal so that you don't make mistake. Of course, the paper should be attached to a drawing board. So that 30 degrees should be around somewhere here. We'll spot it. So having spotted it at 30 degrees, which is the angle of refraction, we examine the first diagram. You can see it will draw a line from that point S, passing through the point to spotted until we meet the point DC at Z. So we're going to draw a straight line that will pass through from S and pass through the point we spotted until it hits the face DC, and that place going to hit is going to be called S. So you can see that the line have been drawn, and you see that that line is passing through that point. You can see the tip point going down until the point Z. You see that we have to include an arrowhead there pointing downward, because that ray is called a refracted ray. It's going out is now moving from glass and then going back to air. So you can see that clearly. The next thing we'll now do is we'll look at the diagram again. What remaining is to draw the ray moving out from Z to air. The ray containing the pin, the magenta ray containing the pin P3 and P4. So we now draw the ray from Z outwards to give us the line that contains our pin P3 and P4. We use the needle to perforate it also to show that it's perforated, that is done actually. Then we'll now put an arrow going outwards. So we'll have that this is a replica of the main diagram. What are we measuring? We're taking theta at 35 degrees, recorded in the table. We're now going to measure the distance SY and also measure the distance YZ. So we're going to measure SY and then YZ. So to measure your SY, you place your rule vertically erect from the point S, that the midpoint, to the point. Okay, that point is SY. To measure your SY, so your ruler should vertically erect from the point S to that point Y. So here we have a half rule. So our S is at 15 cm, and then our Y is around 21.6 or thereabout. So 21.6 minus 15 will now give us 6.5. So our SY here is 6.5. Having measured SY, no, we're not measuring SY, we have to measure SZ. Sorry, correction, SZ and YZ. So please, this is where we are measuring, not the other side. We're measuring the hypotenuse or the triangle. So to measure SZ, our ruler, correction taken, our SZ, we have a 15.2 at the starting point. They're moving 15 at the starting point. They're moving to around 23.2 at the point Z. So that distance there is 23.2 minus 15, and that gives around 8.2. So if your ruler start from 0, you don't have to subtract, you just measure from 0. So this is around our SZ is around 8.2. Okay, we're now going to measure YZ. To measure our YZ, we put a ruler also from the point Y to Z. So that becomes 15 on Y, and on Z 19.5. So 19.5 minus 15 gives us about 4.5 for YZ. So for SZ, we have about 8 point something. And then for YZ, we have 4.5 for angle theta being 35 degrees. So let's see what we recorded in the table. From the table, we see that our YZ, which is 4.5, the same thing as we just got now, 4.5. Our SZ is 8.9, so we are getting also 8 point something, almost closer to what we did before. So you can see is in accordance with what we have. So you do it for all of them. That way you get the SY, YZ, and SZ. Then after you have done it for all the angles, then alpha, you now do YZ over SZ. So divide, for the first one, divide 2 by 6.5, you have that. Second one, divide 2.1 by 6.8, you have that, 0.3088. Third one, divide 2.8 by 7, you have 0.4, and so on. They now find the cos of your cos theta, and your table is now set. So thank you for your time. Remain connected and share this video.